Hi everyone, greetings from NTU. Today I will show you about our research. Entitled, Cryo-Adsorptive Hydrogen Storage, using metal organic frameworks. This research is credited by our team, in School of Mechanical and Aerospace Engineering, NTU. This is our presentation layout. Introduction, methodology, result or discussion, conclusion, acknowledgement, references. Next, this is me, as a presenter today, and this is Dr. MAE-NTU. He is a research fellow in our research group. Last but not least, this is my Professor Anutosh Chakrabarti as my supervisor in this research. Now, the fossil fuel is contributed around less than 80% world energy, and also given the carbon in 36 gigaton to the Earth environment. In this research, we designed the next generation of hydrogen storage to store energy combined with metallic organic framework and deep learning to increase the performance to store energy transfer. The current design of hydrogen storage available in the market have several weaknesses compared to the future design of hydrogen storage. This innovation just because the fossil fuels issue in Singapore. This program is contributed to successful the net zero target in Singapore also for Paris Agreement, respectively. The Type 4 design of hydrogen storage available in the market is poor in low temperature. Thus, the motivation in this study to obtain the new design of hydrogen storage is more efficient and good density. Next, this is the structure of MOFs as a one of porous material. In this study, the MOFs data taken from MOFX database. 137,000 data is used in this study to estimate the model. Here, the input variable and output target are calculated to obtain the estimation. We also analyze the 4-metal linker to see the estimation model. In this research scope, the 4 model including deep neural network MLP and another model like GPR, SVR, and MLR are used to compare estimation result. The 4-metal model used to obtain the best estimation result for 4 isosteric heat of adsorption, QST, and the uptake, Q, at 2 and 100 bars. Next, in this study is very simple method to achieve the result. First, MOFX database such as metallic linker was processed. The second step is feature extraction to obtain the estimation result. Third, all variable goes to normalization to obtain the model. After that, machine learning training from input and output variable, and finally goes to evaluation to obtain R-square and RMSE with best model recommendation of MOF screening. Alright, during training process, deep neural network with MLP architecture was performed in this study. In layer 1 is proposed to initialization of parameter. Layer 2 we use 128 neuron to obtain character properties of value variable input. Furthermore, in the layer 3 to 5 to improve the calculation in layer 1 and 2 with variation between 16 to 64 neuron. This deep neural network MLP use ReLU activation function to obtain highest R-square and lowest RMSE metric, respectively. Next, this is the result of calculation per metallic linker of MOF. As can be seen in the figure, we obtain the estimation value of hydrogen uptake at 2 and 100 bars. The 4-model machine learning also performed to see the R-square value of uptake and isosteric heat of adsorption. The highest R-square is obtained from zinc and vanadium at uptake 102 bars. Furthermore, the Hg-Hest QST at 102 bars is come to zinc material. However, in the low value of R-square uptake and isosteric heat of adsorption at 2 bars and 100 bars, we found that the material copper and vanadium is not performed for all the model. Next, this is RMSE result for all metallic linker. The Q uptake 2 bar with QST 2 bar and Q uptake 100 bar with QST 100 bar was calculated. We obtained the weak result RMSE is come to linear regression. However, in the good result DNN and GPR model are performed. Next, conclusion and acknowledgement. In this study we obtained the DNN and GPR as good model. The linear regression cannot perform due to the lack of iteration to calculate the model. In this research, author would like thanks to NTU for facilities also Northwestern University for hypothetical MOF database. This is our references. And thank you.